Hello everyone, this is question 4 now from Mechanics 2023, and we've got what I think is quite a tricky further kinematics question. So what does it say? It says a particle P is moving on a smooth horizontal plane. The particle has a constant acceleration of 2.4 I plus j meters per second squared. At time t equals 0, P passes through the point A. At time t equals 5 seconds, P passes through the point B. The velocity of P as it passes through A is minus 16I minus 3j. Find the speed of P as it passes through B. Okay, so we've got a constant acceleration, so that's at least something. So I'm going to write down suvat because that is a good thing to write down with constant acceleration. So suvat, and let's just see if we can fill in the information that's given in the question and see whether that's not going to help us work out what's going on. Okay, so we're going to try and find the speed. So what have we got? We have got u. We're told the velocity of P as it passes through A is that. Okay, so we've got that value. V, that's what we're trying to find out. We've got the acceleration is 2.4 I plus j, and we're told it's 5 seconds later when it passes through B. Okay, so we're trying to find, we're not worried about how far it goes in that time. We're just trying to find out what its velocity is when it goes through B. So the suvat that has no s in it is v equals u plus at. So we can write that down and just solve this now. So our u is 16i minus 3j plus 2.4i plus j times by 5, which is minus 16i minus 3j plus 12i plus 5j. And that gives us a velocity of minus 4i plus 2j. But the question is not asking for the velocity, it's asking for the speed, and the speed is the magnitude of the velocity. So we need to square the individual i and j components, add them together and square root it. So it's going to be minus 4 squared, add 2 squared is 20, root 20, which is 2 root 5, and as a decimal that is 4.47 meters per second. So the approach for that one was just, that wasn't too bad. That was just write down suvat. I think the hardest thing was just picturing the fact that it's going through, that's its speed as it goes through A, and then 5 seconds later it goes through B, and we want to know its velocity when it goes through B 5 seconds later. Okay, it's this next bit that I think is quite tricky. So what have we got? It says the position vector of A is 44i minus 10j. So I've just represented here's its position vector. That's where it's actually at. At time t seconds, where t is greater than 5, P passes through the point C. So sometime later, it's moved from A and it passes through C. The position vector of C is 4i add cj. So it's 4 to the right, but we don't know what the j value is. So somewhere along this line. Find the value of t. Now, here's the sort of conceptually difficult thing, I think. We're talking about it starts at A and it goes to C, okay? And we want to try and find the value of t where that happens. So this, if you will, is our S. So going from A to C is the distance that it's travelled. So when we do a suvat calculation, that's the value that we're going to need to be using, the distance, the position vector, to go from A to C. Okay, so how do we go from A to C using vectors? Well, the way we do it is we go A to O and then we go O to C. So A to O plus O to C, but A to O is minus OA. So we've got that to go from A to C, our vector is going to be OC minus OA. So there's our OC and there's our OA. We're going to take those away from each other. So 4 take away 44 is minus 40, and C minus 10 is going to be C plus 10. So that's the position vector that gets us from A to C, which is going to be our S in our subsequent suvat. Okay. Right, so now what have we got to do? We've got to try and find the value of t in which it happens. So let's try a suvat equation and see what we can find out. So I write down suvat. In this case, the displacement from A to C is what we've worked out here above. It is the minus 40i plus cj. The u, we're told that the initial velocity earlier in the question was minus 16I plus minus 3j, so that's its velocity at the point A. Yeah. The acceleration we know is that, the time is t. We're not worried about how fast it's moving when it goes through the point C. So we need a suvat equation then that does not have v in it, so that's s equals ut at half at squared. And I've just put kind of squiggles underneath these just to emphasize the fact that they are vectors. So this is the vector displacement from this is a vector that takes us from A to C. It's the displacement from A to this point C. Okay, well, we worked that out earlier here to be minus 40i minus 40i plus 10 plus cj. Okay, the u is minus 16i minus 3j times t, and then we've got half times our acceleration times t squared. Now, we want to try and find out for the first part of this, for part B, the value of t. And you'll notice that in the I components, if we were to equate the I components, we could get a quadratic in t that we can solve that doesn't have any mention of c in there. So we're going to equate the I components. So that gives us minus 40 is equal to minus 16t plus 1.2 t squared. So I put that into my calculator. It gives me two solutions, 10 and 10 over 3. But the question told us that the value of t was greater than 5, so it's not that one. So t must equal 10. Okay, that's part B done for 3 marks. But I thought that was conceptually quite difficult, having to picture the s as being the vector from A to C. That, I think, was a little bit tricky. Okay, now the next bit, actually this next bit's not too bad now because it's kind of like all over by the shouting for this question. So find the value of c. So as you can imagine now, we're going to equate the j components of what we had a moment ago. So equating the j components, what have we got? 10 add c is going to equal minus 3t, and it's going to be plus a half times 1 times t squared. So we've got 10 plus c minus 3t plus a half times t squared. We already know that the moment that this happens is when t is equal to 10, so we can sub 10 into that equation now, and that gives us 10 plus c is equal to minus 3 times 10 plus a half times 10 squared. So that gives us 10 is equal to c minus 30, and we've got 100 over 2, which is going to be 50, and 50 minus 30 is 20, and then we're going to take 10 off both sides, so that gives us c is equal to 10. So there you go. That is that further, I would say, a tricky further kinematics question. I hope you found that helpful, and I'll see you in the next video.